So,
Yes, sir. Sir, good afternoon, sir.
good
From
afternoon.
from the Department of CSC, Sri Vishnu Engineering College for Women, we thank you for joining with us for this conference as a keynote speaker, sir. Despite of your busy schedule, you are there for us for to share your valuable insights. Before entering to the session, let me take the privilege to introduce you, sir. It is my great honor to introduce Dr. Maheshkumar H. Kolekar. Dr. Maheshkumar working as Associate Professor in Electrical Engineering Department, IIT Patna. Dr. Mahesh did his PhD in Electronics and Electrical Communication Engineering Department in IIT Kharagpur. He did his postdoctoral fellowship in Department of Computer Science, University of Missouri, Columbia, USA. Dr. Kolekar areas of interest are digital signal processing, digital image processing, digital video processing, video surveillance, multimedia communications, signal processing for communication, telemedicine, biomedical signal and image processing, neuroscience, and neurocognitions. And also is interested in advanced biomedical signal processing, deep learning for video surveillance systems and digital signal processing also. He honored and awarded with several awards like Best Paper Award in 4th International Symposium on Signal Processing and Intelligence Recognition Systems in 2018, a Best Paper Award in International Conference Symposium of Health in 2017, guest editor of special issues on biomedical signal and image processing, Journal of Medical Imaging and Health Informatics, American publisher in 2012. He got a Best Paper Award in Computer Society of India in 2004. Sir, really thank you so much for joining with us to share your valuable insights, sir. Sir, you
Okay,
can
thank you.
share your valuables.
Yeah, just a minute. So, with my PPTs are visible.
Yes, yes, your PPT is
Okay.
visible.
I will make it full screen. Okay. So, good morning. Today, I will deliver a talk on artificial intelligence-based surveillance systems to enhance security. So, in these presentations, I will discuss what is the need of surveillance system, what is the need of AI for surveillance system, okay, and how this will increase the quality of the surveillance systems. Okay. So nowadays, CCTVs are installed at various places. You will find CCTVs in the hospitals, railway stations, airports, etc. But the real challenge is um, extracting the activities, abnormal activities, and taking the action. But most of time, the CCTV-based surveillance is mainly a post-event investigation tool. Means something we are recording, some crime has happened, and after that we want to identify who is the criminal, okay, who is responsible for that incident. For that purpose we use. But if we do online or a real time, actually, real time yeah, activity recognition, then at the same instant we can prevent the loss actually. So that's why we have to use AI for CCTV surveillance systems. One of the psychological study has mentioned that 20 minutes of looking at video surveillance screens, the attention of most of the operators fall below an acceptable level. Because actually human has to see many screens at a time, maybe more than 10 screens, okay. 16, 32 screens are there, and he has to watch, one person, our operator has to watch all the screens, and all these events are really boring events, means some vehicles are coming, going, okay. So, so that studies mention that after 20 minutes, there will be a uh, attention loss, okay. Person will not pay attention. And we have done same project actually for airport security. And there we observed that they depute one operator for 8 hours actually. security guy means police for 8 hours. So you can imagine actually 8 hours continuous looking at the screen, whether he will able to detect or take action on abnormal activity. So it's a problem. So that's why we have to provide intelligence. So we will see step by step how we can improve surveillance systems. Okay. So to start with, I will present a small algorithms uh, for activity recognition. So first algorithm actually we develop for loitering action. Means somebody is loitering near an important building, or building like a prime minister's building, office, or any important building is there, and nearby roads are there. Okay, and while walking, if person follow this type of trajectories, we are declaring it as a normal trajectories. Means going in one direction, another direction, or taking one circle and then going, okay, or two circle maximum. So these patterns actually, trajectory patterns we are considering normal. So the user has to decide actually in advance what is abnormal and what is normal. And then we decided that if person is moving in a circular fashion in same loop again and again continuously, like shown in the F or G, then we call it as abnormal trajectories. So based on the abnormal trajectories, we will detect the loitering activities. So we have done this. So just I will show the video. So you can see a small algorithm can provide a great help in the surveillance systems. So this person is moving in a circular fashion. So I have written here safe actually. And after some time, there will be a closed path. So whenever there is a closed path, we can say it's abnormal. So how to detect the closed path? A simple geometrical algorithm is used here. So these are the centroid. X0, Y0 is the centroid of the human. Okay. So first we'll extract the objects from the video. So frame at 0, t is equal to 0, there is a frame, and we'll extract a human, and X0, Y0 is a centroid. Then after a few frames, we will extract another frame. After 5 frames or 10 frames, another frame we have, and whose centroid is X1, Y1. And again, same person's centroid is X2, Y2, X3, Y3, okay, in this way. So here we'll connect this X0, Y0 and X1, Y1. Okay, then X2, Y2 and X1, Y1. So for this X2, Y2, X1, Y1, we'll check whether this line segment is intersecting with the previous line segments. If no, then we'll go for next actually. Okay. So this segment, whether it intersecting with the previous one. In this way, we'll keep checking. And whenever the new line segment intersect with one of the previous segment, we will say that it's a closed path. So person is moving in the closed path. And this is indirectly a loitering movement. So person is loitering near that building or near the important area. So we propose this algorithm. Another algorithm we propose is very simple. Just I will show the video first. So in presentations, I will show simple algorithm first. Then we'll see one method based on HMM, and then some deep learning approaches also we'll discuss. So here is written as a spiral actually. So here what we are doing, at continuous interval, we are extracting the centroid of that blob. This person is there. This rectangle is called as a blob. This red rectangle is a blob, and centroid of the rectangle is very easy. You can compute. And after some interval, we are collecting the centroid locations. So these are the centroid locations in the space. So based on these centroids, we can compute the center of this space actually, XC, YC. Okay. And then we can divide the space into 8 regions actually. So we can draw horizontal, vertical line, and then plus 45 and minus 45 degree angle line. And we'll have 8 segments. Okay. In each segment, we'll count a number of the centroids. Okay. So here number of centroids are 3. Here number of centroids are 3. Here 1. Then in this way, we'll count. And if this number of centroids are more than some threshold, then we can see the person is moving in the spiral fashion. Spiral means every region you will get a minimum number of centroids, and then you can conclude that person is moving in the spiral. So you can understand by using a simple technique, we have detected the loitering activity. Similarly, there are other algorithms. We have developed one algorithm based on hidden Markov model. So it's a probabilistic technique, HMM-based classifier. In machine learning, you might have studied this. So we'll discuss that algorithm in the detail. So here we have a raw video. Our first job is to extract ROI. ROI means region of interest. So how will we extract the region of interest? So very simple logic is there. So background is going to be same. So we'll take the difference between successive frames. So we have frame number 1, for example, t equal to 1, and the next frame is at t equal to 2. We'll take the difference. So since the background is a stationary, only moving parts, whenever the pixels are moving, so that region will get a response. Other place we will get the subtraction as a 0, because same number we are subtracting, same intensity values we are subtracting. So whenever we are getting the difference, we can mark as a white pixel, white color, or intensity equal to 1. And whenever subtraction is 0, we can have intensity 0. So we'll get only white pixels. In this way, binary image you can get. And after that, we'll see the homogeneous region, white colored region, and around that we can put a block or a rectangle, and that is our region of interest. Once we extracted that rectangle, so we will extract the rectangles corresponding to person. If there are 2 persons in the frame, so we will obviously get 2 rectangles. If they are moving, 2 persons are moving. So if we take the difference, we will get 2 rectangles, and so that we are calling as ROI. Then we are going to use optical flow-based method to extract the features. So to extract optical flow-based feature, we have to extract the optical flow first. So what is optical flow and how this can be extracted, that we'll see in the upcoming slides. And after that, once we extracted the features, then we will form a k-means clustering or symbol sequence generation. So we will generate a symbol sequence for that activity. Okay. So what we are going to do, we are going to extract a few frames, and these frames corresponding to which activity that we have to extract, we have to decide. Okay. That's why here clusters are there. So this symbol sequence will be given to the HMMs. In our experiment, we have used 7 HMMs. Each HMM model is for one activity. Like HMM1 is for walking activity, HMM2 is for hand waving activity, HMM7 is for jogging activity. In this way, we can assign. And whichever HMM model gives a better response or highest probability, we can assign that label to that activity. So this is our general algorithm. So let us first see what is optical flow. So there are various methods to compute the optical flow from the video. One of the method is proposed by Horn Chunk. So that we will discuss here. So here is this is the frame x, y, t. Now t frame means image, and image has only 2 dimensions, means x coordinate and y coordinate. Okay, that is the image, and video is nothing but the sequence of frames. So that's why this third variable we are using as the t. T means when t is equal to 0, first frame, or t is equal to 1, first frame. Then t equal to 2 is second frame, t equal to 3 is third frame, in this way. So it's a frame number. And xy is the location actually in the image. So we are going to use this brightness constancy assumption. Means if there is a small movement, the brightness will be same. So that is the assumption. So if there is a move x, if we add some offset, x plus dx, y plus dy, and t plus dt, both will be same. So we can have a Taylor series expansion. So we can expand that Taylor series, and from that we can get this equation. So Taylor series means, so first you will get same actually f x y t, then first derivative, then we have to take the second derivative in this way. So higher order derivatives we have discarded actually, they are going to be 0. So we will have this equation, and here actually fxyt is equal to fxyt plus this, so this will get cancelled, and dou f by dou x we will call as a fx. Okay. So from this we can get this equation, fx into u plus fy into v plus ft equal to 0. So in this way we can compute. So here motion factor, actually u and v represents movement in the x direction and y direction, and we can compute the direction also based on this v and y. It's a tan inverse of v by u. So this is a well-known algorithm. There are another optical flow computation algorithm. One of the method is a Canada's optical flow algorithm. So you can compute optical flow of the image by using any technique. Okay. After that, here we have proposed how to extract its features. Okay. So if you take the first image and second image, we will get the difference, and this is the difference image. Okay. In the difference image, you will find at the boundaries we will get the response, because previous case there was a background, now there is a person present, and here actually previous case there was a person, but now person has moved little bit towards the x direction, this direction, so there is a background. So in this way we will get this contour actually of the moving part. Okay, once we have this difference image, then we will compute optical flow, and after that based on the optical flow we will have a feature vector. So here to extract the features, we have used this algorithm. We will first compute the centroid of the moving part. As I mentioned, computing centroid is very easy. Whatever the blob size we have, blob is a rectangle blob, then we can take the midpoint of this and this, so we'll get the centroid. So this is the centroid. From centroid we'll have a projection after every 5-degree angle. So every 5-degree angle we will have these projections, and we'll compute this A1, B1, C1. What is A1, B1, C1? This line, on this line, how many boundary pixels are there? So there are 3 boundary pixels here. On this radial line, there are 2 boundary pixels, A2 and B2. At this, there is only one, A3. So whenever we are dividing this space actually, 5-degree by 5-degree radial line, so we'll have total 72 lines, and we are extracting the maximum 3 points, okay, on each radial line. So here 3, 2, and minimum 1 point. Okay. So here we got a 3 point because there is a hand actually. B1 and C1 is because of hand. A1 is the
Mahesh sir, can you hear us? Sunil Gara, I think he will join again and he lost the connection.
Yes, sir. Yes, sir.
We'll just wait for some time.
Okay, sir. We'll wait for one more.
Hello.
Yes, sir. You are audible,
You,
sir.
sir, please proceed.
Okay, I will share again. Please
Please.
inform me whenever there's a problem. Okay.
Yes, yes.
I think this my slides are visible.
Now they are not visible, sir. Please reshare, sir.
Okay, just a minute. Whether slide is visible?
Yes, sir. Yes, sir. Please proceed.
Okay. So I already explained this feature extraction method.
Yes,
Then
yes, yes.
okay. So I will discuss henceforth. Okay, after this. So here actually we have to train HMM models for each activity. So we have selected few activities, 7 activities we have selected, and we are training for each activities. And then we have used test video and we can assign automatic labels. So I work on actually these are the videos we captured during my project actually. So these are the videos from airport. Okay. So here my students perform these activities, hand waving, bending with the airport background actually, you can see. So we are able to extract those activities. So here there are some certain challenges like if there are multiple persons in a one block, then you have to extract each person and then perform the activity. So all other things you have to take care. And here our performance is better because this location actually one by one person was coming actually, okay, in the security entry. So that way we have to select the proper location. And this is our confusion matrix. So we got a better results for these are 7 activities, okay. Then another approach we use, that is a MHI based human activity recognition. You can see this video. So here a person is performing jogging activity. So we are declaring jogging as a normal. Then bending as a abnormal. So we can decide actually which activity is normal and which is not normal, okay. Like bending on the road is abnormal. We don't expect somebody is bending there, okay. Or running in the library is abnormal, but running on athletic ground is a normal. So everything is context based. So we have to decide what is normal, what is abnormal, and then we can extract. Like here bending, we can give a red color, okay. So in this way we can extract the activities. And this activity extraction is based on the MHI. It's very interesting approach. MHI stands for motion history image. So let us assume that we have a 10 frames, video of 10 frames, and a person is moving there. Like this person is there, and he was standing actually, and he sit down on the chair, okay. So that process actually we can represent by using the one single image. So this image is the template actually, okay, MHI template for sitting activity. So here there are 10 frames. So what we will do, we'll take the difference between successive frames, like frame number 1, we can subtract from frame number 2. Then frame number 2 we can subtract from 3. Frame number 3 we can subtract from 4, and last frame, that is frame number 10, we can subtract from frame number 9. So every time we are getting the differences, okay. And then we can assign intensity levels, like a latest difference, like difference between frame number 9 and 10, we can assign intensity value as a 10, and difference between 8 and 9 we can assign intensity value as a 9. Then 7 and 8 we can assign another lower number. In this way keep assigning numbers. And intensity between difference between frame number 2 and 1, we can have one intensity as a 1, and after that it's a 0, other things are 0. So because of these differences and assigning these intensities, so latest motion has highest intensity 10, and oldest motion has an intensity as a 1, and 0 means there is no motion, okay. And that's why this image, only single frame, represents the history of the motion. That's why it is called as a motion history image. So I'm representing 10 frames by a single frame, and this is the equation actually given just for implementation purpose, but whatever I explained is the MHI. So this is the image. You can see here dark intensity levels, because that time person was standing actually. Latest motion represented by the brightest pixel, okay. Same thing is here, hand waving actually. So he started lifted hand actually when hand is in the highest position. So that time we have a darker color, brighter color, and old motions we have a blackish color. So in this way we can generate the templates. So if we have 7 activities, we will have 7 different templates, and then we will store these templates in the database. For unknown video or new video, we can extract the template, and then we can compare the templates. And based on that, we can assign the label. So we have used this template-based approach also for extracting the activities. Another activity, like this is very interesting activity, climbing up and climbing down, fence climbing activity, you can say. So this is usually unwanted activities, like for your house, there is a gate and somebody is climbing up the gate, okay. So we can put the alarm there, okay, or you can check actually. So how this can be done automatically. So we have used a simple algorithm. Like we can extract the centroid of the moving object, and here whenever he is climbing up, the centroid means X coordinate is going to be same, Y coordinate is only changing. So by extracting that type of features, we can detect the fence climbing activity. Another activity recognition, here you can see there are 5 persons standing here, but based on the intensity difference, actually I got this block, big block, and now actually they are separating. Okay, and now I can assign the labels 1, 2, 3, 4, 5. So from one blob, actually 5 blobs generated, new 5 blobs generated. And so that's why I can say that this is a dispersion activity. Similarly, if the blobs merge, actually there are 5 persons coming in different directions. And if they merge at some point, actually, then we can say as a meeting activity. Persons are meeting. Okay. Usually during the curfew time, there is a rule actually, like not more than 4 persons can gather together at a public place, like roads or roads or bus stop or stations. Okay, so that time this type of algorithm can be used. Another actually here you can see, here we can track the moving persons actually. Okay, so here this lady is moving, this person is moving. This is an airport scenario. All persons, there is a less movement, so they are considered as stationary, because it is difficult to track those persons. Okay, to avoid, to make simplicity, only a high motion or objects moving with certain speed, we are tracking them. So in this way, these things can be used. Another algorithm we have used for vehicle tracking actually. So we have a recording actually, an aerial video recording of the moving car, and we can spot that car and we can track that car in the video. Okay, so these are some of the applications of human activity recognition, and we have seen by using simple algorithms we can add value to our surveillance systems. Okay, because we know the limitation of the operator cannot detect abnormal activity easily, because he had to watch many videos. So that's why if we provide such a small algorithms and provide intelligence, that will be great. Nowadays there is a lot of work, actually people are using deep learning based approaches for anomaly detection, and these are the standard data sets available. Avenue data set, then UCSD paid one data set. This was developed by University of California. Paid mean pedestrian database. So 2 databases are available online. Then another is a human data set. So one can use this data set. So you can see this is the data set in the campus. Actually, these are roads in the campus. Okay. So there's a rule, actually they don't want a cycle in the pedestrian path. So we can say this is abnormal. Okay. If somebody is entering with the cycle, actually, so immediately there will be alarm, actually will be detected automatically. Similarly, this is avenue data set. So running, actually, okay, running or with cycle or throwing book, okay, these are some of the cases they have considered in the avenue data set. There is another data set called as a human data set. Here they have considered moving scenario of the group, actually. So this is the lunch time or free time, people are walking there in the campus, but suddenly they are moving in different directions. Okay, all these persons are moving as if there is a bomb or something is there, so moving. Okay, so that can be recognized as a abnormal. Same thing in the mall, actually there is a road, outside road, and people walking normally with normal speed, but suddenly the speed of persons increase, and with the different directions, actually they are moving. Same scenario they have considered here also. So here in second case they are moving with some speed. So and all persons, means crowd is moving actually. Okay, and in different directions, so they have considered this as an abnormal scenario. So you have to detect that. UCSD paid one data set. They have considered like coming the vehicle. This is a vehicle in the walking street, actually. This path is for pedestrian for walking purpose only, and now there's vehicle. So all these abnormalities can be detected. So what are the challenges in using supervised? So here actually whatever method I discussed, HMM based method discussed. So there we in advance we know the type of abnormalities actually, but most of time we don't know the abnormalities. We know the normal routine. So we will train the model, actually deep learning model, with the normal routine, and if there is a abnormality, so there will be error actually, and that's why people started using this auto encoder model actually. So what we will do, we have image actually here, we'll encode it, and we have compressed data, we'll decode it and we'll reconstruct it. Okay, and now we'll take the difference between this. So there will be some loss or some difference, some error. Okay, so but error is in within a threshold. Okay, now we'll train this with this known image. Okay, image of the Lina encoder decoder, many images actually, and now okay, so this model is trained for this known data set, and now if we input an unknown image, like image of the car here, okay, instead of the face, so the model, this model will struggle actually, okay, and the output will get something different, okay, lot of loss. Okay, so whenever the loss is above certain limit, then we can say that there is some abnormal activity, because here instead of face actually we are giving the vehicle image, so that's why abnormal. So this philosophy is used for abnormality detection in this case. So this is very popular algorithm, autoencoder. So same thing we are using for activity recognition. So here it is explained with the number data set. So this is number 4, and reconstructed image is also this. So we'll take the difference. Okay, so there are different types of autoencoders also. So we have used a spatio-temporal autoencoder, which uses convolution layers and RNN layer. So this is the architecture. So we are doing the input image, and then some few convolution layers, then temporal encoder. So this is the encoder part. So just reverse order actually, we will have decoder and then special decoder using CNN, and we can reconstruct. And reconstructed video case, we are going to take the difference. If difference is above threshold, then definitely something unknown is coming actually, really not expected, and that's why we'll say as a abnormal. So you'll find a lot of papers based on this approach. So it is all about the reconstruction error. So we use autoencoder to learn regularity in the video sequence. So routine videos we will give to the autoencoder, and whenever there is an abnormality or new video, then there will be more error. So this is the flowchart. So we'll compute the error. Error is above threshold, then we can say that it's an abnormal clip. Above threshold means abnormal clip here, true. And if threshold below threshold actually, the reconstruction cost, then it's a normal. So here during training actually, we are doing the raw frames, and these are the raw frames, and we are doing the raw frames to this LSTM autoencoder, con LSTM autoencoder, and this autoencoder will generate a raw frame. So original raw frame minus the generated raw frame will take the difference. Okay, so that is Euclidean loss. In this way, model will be trained. Okay. So why using convolution layers in the encoder and deconvolution layers in the decoder? So convolution layers connect multiple input activations within a fixed or respective field of filter, single active. Okay. Actually, we want to extract the special features, special domain features. So we are using a convolution layers, and LSTM actually is good for temporal feature actually, sequence actually. So this is the model. So while testing, once model is trained, while testing, we are again providing the raw frames to the autoencoder, and we are computing the reconstruction loss cost. Based on that, we will have a regularity, and we can plot here regularity versus frame number. We want highest regularity. So these are the regular frames. So here you can see 180 frames are there approximately. So for every frame, there is a regularity score. So regularity score is above threshold. Like let us put the threshold as a 0.8. So something above 0.8 we are saying regular, and below 0.8 we can say irregular. So this region definitely there is a irregularity. Like a vehicle entered in the video, that type of scene may be there. So that we have to check. So this is the nice approach based on the autoencoder. Okay, reconstruction loss. So these are the equations actually for complete frame. Actually, we can compute the error. So EXYT. Okay, so T is constant. Only XY is changing. So all pixels actually we will have error. And how to compute EXYT is given here. So this is the image, original image, and FWIXYT is the reconstructed image. Actually, we are taking the difference. So after that, we'll have a sequence reconstruction cost. If there are 10 frames, then we collect the error for 10 frames, and then we will have a abnormality score. We subtract the abnormality score from 1. Normalized abnormality score from 1, definitely we'll get a regularity score. So we are expecting high regularity score for normal activities. So we tested on UCSD data set and we observed these type of curves. Okay. So these are some of the references, and these are the related papers. So this is my book recently published. Means in 2018, Intelligent Video Surveillance Systems, Algorithm Approach. So so many algorithms, around more than 20 algorithms are given in this book. That HMM-based algorithm is also available in this book. If you want to use, then can you refer this book. Thank you.
Thank you, sir. It's a privilege listening to you online. Thank you very much for accepting our invitation. Sunil.
Yeah, sir. Sir,
Sunil.
thank you so much, sir. Because nowadays it is going to become as a very tricky part to identify who is having some odd behaviors and all, because we are facing this problem, especially in India. So
Right.
you came with this idea of how we can make prediction with this surveillance and all.
Right,
So
right. How to extract activities automatically means.
Yes,
Because,
sir. Yes, sir.
Because we cannot pay much attention, and human
Yes,
has
sir.
a limitation.
Yeah, even our surveillance is going to do everything.
Right.
Really, it is useful for us, sir. Thank you so much for giving such a grateful information, sir. Thank you so much for joining with us, sir.
Thank you. Any question I can answer if there is a question?
Participants, you can interact with sir. If you have any query, please unmute yourself and you can ask a query. And your presentation is so clear, sir. Actually,
I don't think no one will ask any questions, sir, because you gave with a real-time example and following its algorithm, how the algorithm is applicable in the survey videos and all. So it is very much clear, sir. I don't think no one will have some queries and all.
Okay, no problem. Yeah. Thank you.
Thank you so much.
Sir. It's a privilege listening to you, sir. Thank you very much.
Thank you. Goodbye.
Thank you, sir. Have a nice day.
Okay, thank you. So shall I leave the meeting?
Yes, sir. Yes, sir. Please.
Okay, then.